I'm now going to show you how to do problems 1 through 4 on the Chapter 6 review packet. So for this section, we need to start with identifying the length and the width of our rectangle in order to utilize that to find our missing probabilities. So for this section, we have a length that goes from 0 to 5. So to find length, we simply take our highest value and subtract the lowest value. So the length of the entire rectangle is 5 units. Our width is missing. We need to identify that. And if we are assuming that our entire distribution is contained within this one rectangle, our area would need to be 1.0. That is because the probability is represented by the area of the rectangle. So if we have the entire population consumed within this rectangle, we have 100%, which is a probability of 1.0. That's where that number comes from. So to find our width, we take our formula of area equals length times width and plug in the two numbers that we do know. The area is 1.0, our length is 5, times our width. So to solve for W, do the opposite operation, which means we need to divide by 5. So in this case, our width will equal 1 divided by 5, which means W equals 0.2. That width is going to be consistent for every problem with this particular section because we're working with the same information all the way through. Now for the actual problem 1, it says that the probability that we're looking for is a random variable that has a value greater than 0.4. So that means I'm going to come over here and I'm going to estimate where I think 0.4 would be located. I think that's about where I'd find 0.4. And I want the values that are possible that are greater than 0.4. So that means if I'm shading in here, I'm shading in almost all of my rectangle. So if I was to anticipate an actual probability, it would be something that's close to the 90% or close to 1.0 itself. So it's the majority of our original rectangle. So now we go back to our area formula, only this time we're thinking probability is length times width. And in this case, our length has changed. It's no longer 0 to 0.5, it's 0.4 to 5. So the length is actually going to be 5 minus 0.4. So our new length for the problem number 1 will actually be 4.6. So our probability equals, sorry my paper's a little bumpy, our new length of 4.6 times the width that we determined, which was 0.2. Again, that width is going to be consistent because the height of our box is not changing, just simply the length. When we multiply those two numbers out, we will get 0.92, and that is actually our very messy but final answer for problem number 1. So now I'm going to do problem number 2. Again, we've already calculated the width of our rectangle. That work is already done. It is 0.2. So the question asks, what is the probability that the random variable has a value less than 2.0? Well, if this is supposed to be 2.5, I'm going to guess that 2 is about here. And I want the values that are less than 2.0, so I want all of the values that are over here. What's the probability of finding a value in this section? So again, we're going to start with calculating our length. And that's going to be the highest and lowest values being subtracted. The highest is 2.0, the lowest is 0. So just for showing my work, the length of my rectangle is 2. So now back to my probability, length times width. My length is 2, my width is 0.2, so my overall probability is 0.4. And that's how you tackle problem number 2. Problem number 3. What is the probability that the random variable has a value between 1.5 and 3.5. Well, now instead of using a top or a bottom of the box, I now need to put in 2 vertical bars. One where I think is about 1.5 and another one at about 3.5. So I shade in this region so I give myself a visual of what I'm working with. So again, start with your length. The length of the section that I'm interested in is going to be the highest value, 3.5, minus the lowest value, 1.5. And again, in this case, the length is 2. Now, we had a length of 2 on the previous problem. The only difference between these two problems, then, is the position with which this section is located. Here it's at the beginning of the original rectangle, and here it is in the middle. But if the length is the same and the width is the same, which it is, then our probability will also be the same. So probability is length times width. So my overall probability is again 0.4. So for problem number 4, again the width is still maintaining at 0.2. And we want to find the probability of finding a value that's between 1 and 4.5. So here is my estimate for 1. 4.5 maybe around here, and the area is the shaded region in here. My length is my highest value minus the lowest value. So 4.5 minus 1, which equals 3.5. And now we can calculate our probability. Probability equals length times width. So we have 3.5 times our width of 0.2, which was consistent for all of the problems. And our final calculation here is going to be 0.7. And that's the probability of finding a value that is between 1 and 4.5.